All right, so I'm going to introduce Terry. Actually, Clint is going to go first. Clint Skelly is from the National Weather Service, and he will do the Skywarn part of the training. And then we'll have Terry after that will talk to us about the Skywarn net and give us the information specifically to us for how to do that.
Yeah. All right. Good evening, everybody. Thanks for having me up here. My name is Clint Skelly. I'm the Warning Coordination Meteorologist with the National Weather Service in Pueblo, Colorado. A couple other people came before me. The original WCM, it's the acronym for my title, is Tom Magnuson. I'm sure you've all met Tom Magnuson. Afterwards was Greg Hebner. And so I'm the third Warning Coordination Meteorologist with the Weather Service, just trying to keep up with all the great stuff that they've done. But we're going to talk about spotting today. It's a whole new presentation since I think the last time you all saw it. If you've been trained here before. So hopefully a couple new things for people to learn. We've incorporated a little bit of fire, a little bit of winter, stuff like that. But this is the advanced course, so we're going to deep dive into the meteorology a little bit. So I'm going to nerd out a little bit. How about that? It's my most favorite thing to do about spotter courses because, believe it or not, I'm not like a huge severe guy, but it's weather. I still really, really like it. So anyways, let's get started. So why do we need spotters? Well, it adds a whole bunch of credibility, gives us confidence, helps with our operations. Ground truth is great. We have limitations on radar. We have all these different things. So in this particular place, adding credibility. So think about if we have a severe thunderstorm warning that's been issued over an area, but we, I guess, put in a warning in the text for, 1.5-inch hail. Turns out just a bunch of small P's. Well, that gives us credibility from you guys giving us ground truth to cancel that warning right away. Or conversely, if we have, say, 1-inch hail in our warning and you got 2-inch hail at your place or wherever you're spotting, we can change the text product in there and update the people who are downstream of you all. So just because we maybe got it a little bit wrong for the warning for you all who were impacted, your neighbors downstream also need the best information possible. I think this is one of the most, the best types of citizen science in the nation. It's you all helping the National Weather Service get better warnings out there. Radar limitations are a thing too. It's not too bad here. Our WSR 88D, our weather radar, is located in northeastern Pueblo County, and it actually samples things quite nice up here. But still, you're not going to see the very bottom of the storm on a lot of these storms that develop here. The radar's just angled a little bit too high. So ground truth about what's actually happening at the surface is very important because we're making some assumptions based on pattern recognition and understanding different kinds of radar patterns. But still, weather's weather. The ground truth could be a little bit different than that. So that's why we need you all. The last thing, and since we're really close to the Palmer Divide, there's quite a bit of weak spin-ups that develop up here. Radar, it's pretty hard to see those really weak spin-ups that develop. So letting us know this kind of stuff is important as well. We don't issue any more spotter IDs. This is something that went away probably, I think, 4 years ago under Greg. It was a database nightmare, to be honest. If you have a solid hour to talk about it, we can do that later. But we don't do that anymore. At the end of this course, however, we have our weather.gov/PUB. I guess it's /PUB/spotters. It's a website that we created that prints out a certificate, so you can hang that thing on your fridge if you want. I know I will. And then also you get a hail card there that you can laminate afterwards. So now that that's out, here's the outline. To talk about the National Weather Service, what our office is, what we do, an overview of weather hazards and safety, reporting overview, and then this is new, I guess, as of 3 years ago, a spotting simulation as well. So we're going to give you some scenarios, going to ask everybody the question, how do you report this? Tell us how you do it. So that's a little bit of interactivity for this presentation. So what is the National Weather Service? Well, we forecast weather. There's 122 of our offices across the United States and our territories. So you can see down here, even in Guam, we have one. In Alaska, we have 3. If you think about it, Alaska's like this big. and we only have three warning forecast offices covering that area. Granted, there's not many people up there, sure, but there's probably a magnitude of tens that forecast for the same area, uh, uh, same area. But we don't care about Alaska in this presentation. We care about Colorado. So there are 4 different offices that forecast for Colorado. The West Slope in eastern Utah is from the Grand Junction office. The Front Range in the northeastern plains, all the way up to Sedgwick County, is the Denver Boulder office. Goodland, Kansas even has a couple offices that they forecast for on our far eastern plains that border Kansas. And then, of course, we have Pueblo, my personal favorite of the offices. Other than that, we have 6 major regions: eastern, southern, central, western, Alaska, and Pacific regions, and river forecast centers that are co-located with some other forecast offices. But again, we don't really care about those places, do we? Let's talk about southern Colorado a little bit. So this orange outline, this is how we, that's the border of our area of forecast responsibility. The first question is, why do we have the chicken leg up here? Does anybody know the answer? Don't be shy now. Yeah, that's it. The Arkansas River starts up at Lake County and goes all the way to the Kansas border. That's a major watershed in Colorado, so they figured, why not give it all to one forecast office? But that also creates a lot of variability with topography in our forecast area. So you can see some of the biggest mountains are located in the Swatch Range and the Continental Divide. In fact, the biggest mountain of Mount Elbert is the tallest mountain in the contiguous Rocky Mountains. Not the tallest mountain in the United States, of course, but in the contiguous Rocky Mountains it is. So we go all the way from, the Continental Divide down to the New Mexico border. We got the San Luis Valley. And I keep telling myself every time I do a presentation, talk about the San Luis Valley, that's the largest type of valley of whatever valley it is in the world, which is amazing. But it's a very large valley. The craziest weather happens there. And it's in our forecast responsibility. So we have the Upper Arkansas River Valley, the Wet Mountain Valley, and then we follow along to the Lower Arkansas River Valley all the way to the Kansas border. Of course, our largest population center is Colorado Springs, getting close to 1 million in the entire county. And I found out not too long ago that El Paso County is the most populous county in Colorado. You would think that would be Denver area, right? But it's tiny, and El Paso County just encompasses more people. So didn't know that until not too long ago. But of course, El Paso County has the Palmer Divide, goes down to Pueblo, 4,700 feet, and then back down to the Raton Mesa on the border of New Mexico and Colorado. So big topography differences there. But the lowest topography is out in the far eastern plains, just east of Lamar, is the second lowest spot in Colorado. So if you go from the lowest spot to the highest spot, that's roughly 10,000 feet elevation difference between our high and low points in our area, which is the second most prominent gain in all of the Weather Service offices. The first is in Hanford, where they have Mount Whitney, and they're almost down to sea level there. So interesting stuff there. We get all kinds of weather, though. The only thing that we don't get really is tropical. We might get some tropical-based moisture, which is, causes flooding in our area, but we've never had a landfalling, tropical depression, tropical cyclone, of course, go into Colorado. So this is who we are. There's a few people here that aren't supposed to be here. They're from Central Region Headquarters, the man, if you will. So these people, they're visiting. These people, those are the people who I work with every day. That's the outline of what our office looks like. We have one meteorologist in charge. His name's Charlie. Just started, probably 8 months ago or something like that. Really good guy. There's one me, morning coordination meteorologist. We have a Sue vacant, the science and operations officer. We have administrative support. We have electronic analysts, people who keep our radar running, our surface observations running. And of course, we have the hydrologist, Justin Lewin, and then our forecasting staff. We have 6 lead forecasters, and we're a little short-staffed right now, but when we are fully staffed, 6 general forecasters in our office. We work 24/7, 365, some years 366. We're always there. We have a minimum of 1 person there, generally 2 people there. Yeah, we're always, weather never stops, right? So we're always monitoring. sometimes it's quiet weather and we can focus on projects, but other times it's what, 3 to 4 feet of snow over the Palmer Divide. So, and that's just what I said. And this, I need to update this too, because we literally just changed for the first time ever our start times for our shifts. Instead of it being 8 a.m., we're starting at 7 a.m. and we go to 3 p.m. or 3 p.m. to 11 p.m. and then 11 p.m. to 7 a.m. That's our main shifts now. So anyways, we issue all the watches, warnings, advisories for our area. So every time your phone goes off, that's my office saying that, hey, there's a severe thunderstorm. Perhaps maybe think about doing something. You know, I'll talk a little bit about the thresholds that actually get to your phone now, since they've been recently updated as a few years ago. But we forecast weather. That's what we do. I shouldn't say just that too, because I'm here tonight, right? So we do a whole bunch of outreach. We work with Colorado Department of Transportation, local emergency managers. You know, we give information, you know, as a here you go, decide what you want to do with it, and people make action from the information that we give them. It's a really good job. It's a fun job. So WSR 88, WSR 88Ds, there's 155 of them. They're located obviously across the nation, but the one that we care about is KPUX. It's located in northeastern Pueblo County. We also care about KFTG bit because that gives a really good look about what's happening in Teller County. KPUX is actually blocked by Pikes Peak, so there's parts of Teller County that we can't actually see. So we have to use the Denver radar to see those areas. In fact, we used that with that Pikes Peak tornado that happened on August 8th last year. I think that's what it was. We used KFTG to decipher that and see that. So it's really good. This is a really good technology. It's really simple technology. All it is, it's a radar, bleeps out some radiation. You guys are all familiar with that, right? It goes into the cloud and it comes back with a scattered or reflectance off of the hydrometeor, whatever it is, and then we can decide we can interpret what the radar is stating from that information. So if it's more reflective, potentially means hail. If you know, the radar actually shows velocity, so you can see where the air is going. But it has its limitations. There's a lot of side lobing effects. So if there's big hail aloft, some scattering off the side of that hail, say, would make it look like there's a tornado in the lower levels. These are some of the things that we have to figure out. So it's not a perfect tool, but it's a really good tool. We use it, I mean, all the time. People are familiar. Base reflectivity. So this is what a severe thunderstorm kind of looks like. In particular, this is a really strong storm located in Kiowa County here, but this is base reflectivity. So you can see those areas of like the purplish kind of colors, the dark reds. It's likely hail. There's probably hail located in that area right there. If you go a little bit further north, it turns into a little bit more heavy rain. And if you go to the northeast, it's primarily just light rain. So again, all this shows is just the reflectance of energy off of the hydrometeor that's in the thunderstorm. It'll pick up birds, it'll pick up dust, it'll pick up insects, whatever's up there. It'll pick it up. This is base velocity. So our radar is right here. It's more like right here, I guess, but northeastern Pueblo County. This is Kiowa County right here. It's Shippington, Sheridan Lake. So anyways, the thing to note though, when you're observing radar products, you have to always know where your radar is because certain values mean certain things. And in this case right here, the values of green mean that the air is going towards the radar. The areas of red mean that it's going away. And so in a three-dimensional space, because this is just the one-dimensional, or go from one-dimensional to two-dimensional, you have to kind of infer that air is rotating counterclockwise or cyclonic in the northern hemisphere. So that point right there is inferred rotation. We're concerned about tornadoes or maybe wall cloud or at least a very strong thunderstorm. Another kind of technology that we do use is satellite. I was just down at Space Symposium and I was able to brief on NOAA on a sphere or science on a sphere using satellite data. It was really awesome, but this is our latest and greatest in satellite technology. It's from 2017. That's when it was brand new, and we're doing a bunch of case studies, grabbing data. But using satellite, you can actually infer where thunderstorms are going to develop in the near term. So you can do all the forecasting you want, but at the end of the day, it's going to be, looking at observations, trying to understand what the atmosphere is actually trying to tell you, and then, putting out warnings and things like that. So in this case right here, this is what the atmosphere is trying to tell us. You see this line right there and all these clouds that are bubbling up. Those are cumulus congestus. That's just the area where air's trying to rise and become a thunderstorm, but it's not quite getting there yet. Especially, of course, this is the Palmer Divide. You got the Palmer magic that's aiding in the development of thunderstorms right here. But essentially all we're seeing, air trying to turn into thunderstorms. So if you think about it in like a thermodynamics kind of way, in applied physics, say you got a stove, right? Put it on your, or a pot you're putting on your stove, and you're boiling it, starts to bubble, right? That's heat transfer. Air, that warm air at the bottom of the pot is going up. It's convection. Same thing happens with the surface. Air gets lifted a little bit. It's warmer than the air around it. Warm air rises. It has to go up. That's the basic 101 of what a thunderstorm is. It's air trying to rise. And once that air rises and goes into a colder environment, it has to continue to rise until the environment around it is the same temperature or warmer than that blob of air. So anyways, we can see that. You can see all that, all the bubbles trying to convect right there. Eventually, you can see there's some sort of wave that develops thunderstorms over the mountains, and eventually, it's kind of choppy, but eventually it does go over the Palmer Divide and create some thunderstorms. Back in the day, by back in the day, I mean 2016, that was the last time that we had GOES 15 data that we really analyzed. GOES 15 data was an image from our satellites every 15 minutes. We now routinely get data every 5 minutes. So it's like essentially going to sleep one night, waking up, and then like actually seeing what the atmosphere looks like. It's amazing. But this is probably the biggest advance in meteorology for quite some time, at least operational and forecasting meteorology. If you get it right, we have a GOES West and a GOES East. So these are geosynchronous satellites, but if you can overlap their imagery over each other, you can get up to 30-second resolution. That's pretty incredible. So anyways, I'm geeking out. I'm going to take many drink breaks, by the way. Bear with me. So we're going to talk about Southern Colorado weather. Got the severe thunderstorms and the tornadoes, wildfires, flooding, flash flooding, and then a little bit about winter storms. Not going to talk about the science about winter storms, just or a little bit about the science behind the wildfires, but primarily just how to report it. So hail is the most common hazard in Colorado. That's why insurance premiums are so high, more or less. But you can see, not all hailstones are made equally. These are about the same size, technically. First off, how do you measure these hailstones up here? The widest point, exactly. So in this case, be that tip, but that looks a lot less bulky than this, right? Like that feels like that would really hurt a car or your head. This maybe a little less so. So yeah, these kind of things are important to know. If you're giving us a call, be like, yeah, it's technically 2 inches, but there's some stuff missing from it. Like, that's a baseball. So anyways, we get all types of hail. You get plowable hail events, which look really bad on radar, but end up just being a lot of peas that just continue to accumulate on each other. And then we can go all the way up to really large hailstones. I forget what the record in Colorado is. I think it's like 4.5 inches or something like that. It fell over the Eastern Plains, way over Kansas, nowhere here, thankfully. But yeah, so hail, most common kind of hazard in our in Colorado. Yeah. Do you have a name for that kind of hail? Distinguishes it? No.
Can you repeat the question for the people?
Oh, yeah, sure. So the question was, is there a name for the type of hail that's located on the top? So like the really spindly stuff. And just, we don't have a name for it necessarily, but it just develops a little bit more differently, right? And so the points that the water droplets are forming on, the ice essentially aggregating just goes off in a spindly way. I think the bottom ones are a little bit lofted, a little bit longer. I'd probably assume that the bottom one is stuck in the updraft a little bit longer. It can like tumble a little bit more and develop, whereas maybe the updraft on the top one's a little bit weaker and can fall a little bit more quickly. So it was probably really cold in that thunderstorm anyway, too. Thank you for the question. So other things that we want to report, wall clouds. This is the action of where all the action of the thunderstorm is. And so this is one of my favorite images here in the upper left for you all. You can really see the structure of the thunderstorm. You can see the wall cloud right in the middle. You can see the inflow coming in. It's just a prime example of what a thunderstorm or a severe supercell would look like. Other things are a little less clear than that, but other things, this is a wall cloud right here. You know, if you're observing this, it might not necessarily rotate, but it likely is. But if you start looking over here, this is where the action really is. That's where the tornado would develop right there. And this upper right-hand corner, again, here's the wall cloud in general, but at the bottom here, this is where we're going to be trying to observe where tornadoes are. And then once again, located here, of course, that's just what a wall cloud looks like. In Colorado, we have a lot of low precipitation supercells. It's really dry here, right? And so it's really hard to form a cloud sometimes, which is really good for observing because some of the most picturesque tornadoes out there are in Colorado or Wyoming or New Mexico, places that are closer to the mountains. Other places aren't so lucky. That, for example, if you go chasing out in like Arkansas, it's not great. You know, it's really moist atmosphere down there. You're likely going to get a high precipitation supercell. Plus, you have all the trees. It's not a great place for severe weather. That's why it catches some people off guard because you don't know what's coming. You just got a big wall of rain coming towards you. In that rain, there's a tornado. So thankfully for us, it's pretty rare occurrence that we get a high precipitation tornado. That being said, though, the one time I went chasing out, maybe it was like one of my 4 times I went chasing out here, I had a high precipitation tornado. Couldn't see anything, and it just was moving like 60, 70 miles per hour south. And yeah, it was more dangerous than but yeah. So tornadoes, of course. This is, you know, we're all the enthusiasts. They love seeing tornadoes. See, I'm more of like a winter weather kind of meteorologist. I love the interactions of the mountains and the snow, the 2 to 3, 4 feet of snow on the Palmer Divide again, which is remarkable. But a lot of people like the tornadoes. And rightfully so. Some of the strongest winds on Earth are associated with tornadoes. They're fascinating things. The one thing that is to note about this, though, the tornado doesn't have to have the condensation funnel hit the surface. As long as you can see debris at the surface here, then it's a tornado. And there are better examples of this later, but at this point right here, does that look like it's touching the ground? Actually, we don't know because there's trees in the way, but the condensation funnel definitely is not. Now, if it's creating a little bit of debris behind the trees, still a tornado. Even in this case right here, it looks like a tornado, but the curvature of the earth, can you see what's happening at the surface? I would say possible tornado, though it's likely a tornado. So winds. We have all types of winds in Colorado. We have winds associated with thunderstorms. We have winds associated with really weak thunderstorms. We have downslope windstorms off the mountains. We have cold fronts that come through really, really quickly. Tomorrow, expect a cold front coming through. It's going to be really strong. We have all kinds of winds, but they all cause damage. And this is another, you know, again, it's going to make it seem like I just dislike tornadoes, which I kind of do in a way, but like they cover such a small spot, but to get all of the attention from everybody. These things cover miles. And this my goodness, this shelf cloud right here likely has severe criteria wind underneath it. And it's affecting much more than just a few square, feet in Colorado. So a little bit more impactful than, you know, tornadoes in southern Colorado, to be honest. And they can be as strong as a tornado. You know, we've had these kinds of shelf clouds and thunderstorms develop straight line winds of greater than 100 miles an hour. It happened 2 years ago in La Junta, recorded 100-mile-an-hour wind gusts come through. No tornado around. causes damage like this too, of course. Flash flooding is always a thing. Flash flooding is becoming more of a thing too, especially after fires. You know, essentially, it's one of the easiest equations in meteorology. Flash flood is rainfall rate times how much, right? So if it rains a lot in a short amount of time, flash flooding is possible, especially in places like Colorado where we don't get a lot of moisture. A little less of an issue up here, I would say, but say like on the, I don't know, around Pueblo or something, where the ground's really dry, it's hard to infiltrate, just turns into runoff. So, and then the other thing to note is not a lot of it can cause some impact. So 12 inches of water can cause something to float. Even the biggest trucks out there cause it to float. In fact, the truck's tires are so big, maybe they're more buoyant, right? Who knows? But the other thing to really talk about is the when flooded, turn around, don't drown thing. So be honest, how many of you driven through standing water? Should I? Actually, I haven't. But, you know, you don't know what's going to be going on underneath the water. Water is a powerful thing. It's heavy, it's dense, it's flowing. It can take out a road really, really easily, or just mangle it like you see right here. And later on in the presentation, we have an actual example of a culvert that busted and got blown up due to rushing water, and the road's gone. You know, that's something that if you're going to go through the water, that's something that's a risk that you have to take. We're saying don't take that risk and try and find another place. Of course, you know, trying to get to your final destination that's right there can be very frustrating, but we always recommend not driving through it. Turn around, don't drown. So lightning, very, very common in El Paso County. I'll show you a map a little bit later that illustrates that really well, but lightning is as hot as the sun. It's hotter than the sun. It's plasma. It's very hot. Essentially, the Earth can be like a battery sometimes, discharging electricity from positive to negative. It's, in theory, really simple. And the one thing is, lightning doesn't really care where it goes. It's just following the path of least resistance. And if that path of least resistance is, you know, a tower, a tree, or you, that's the path of least resistance. And so, you know, the things that we're saying, you know, up here, when thunder roars, go indoors, or for, you know, people who are hard of hearing, you see a flash, dash inside. That's stuff that we really, really take, you know, very seriously. In Colorado, lightning is one of the more dangerous things. A lot of people like to go outside. A lot of people like to go out hiking, which are closer to the clouds and closer to the electricity. So, yeah, we really recommend, you know, if the thunderstorm's around, try to go inside, or at least plan around it, right? So if you're going hiking, maybe get off the peak by 11 a.m. if you can, things like that. But again, lightning does not discriminate, and it can strike miles away from the storm. This is my favorite photo from all of it. So this guy right here, Steve Hodanish, lead forecaster, huge guru of, you know, just thunderstorms in general, likes to storm chase. The one thing, like the Storm Chaser 101 thing is like, stay away from power lines. It's remarkable. That's not the point of this. The point of this is that, like, notice how the updraft or the lightning strike is far away from the updraft, that being the updraft, that being the downdraft. But the real thing is, don't be like lead forecaster Steve Hodan. It should take a photo of thunderstorms by that. It could very much, you know, get electrocuted. You know, winds could topple it over. A live wire can be by you. So yeah, don't be ho. So this is fascinating. So this is Colorado lightning statistics from 1996 to 2016. It's a heat density map of where lightning strikes. Anything stand out? Pikes Peak region. So the reason being, mountains really like to help create thunderstorms. We're on the plains mountain interface, right? So we get a lot of moisture from the Gulf of Mexico that's going towards our mountains that help develop thunderstorms. That's why you don't see as many thunderstorms located in, say, central and northeastern Colorado there. All the moisture is coming up from the southeast or east or wherever it wants to come from, goes over our mountains, creates thunderstorms essentially every day over Pikes Peak region. But What's the most electrified or electrocuted due to lightning place in Colorado? Castle Rock, that's one. Any other guesses? Pikes Peak, that's a good guess. Pikes Peak is the most struck 14er. So, not Mount Blue Sky. It's actually located in Washington County. It's just a tower that's really tall. I got you all right? But yeah, I think by like square area, sure, Pikes Peak region, Teller County, El Paso County, but there's one tower in Washington County that's taller than the rest. The really cool part is, I'm not sure if you can see the line right here, but say right there, you see how there's a little minimum? That's Highway 24 going into Teller County. The valley protects it from getting struck by lightning. It's hitting too many other things. So lightning flashes per day climatology. So if you go down the bottom, you can see on the x-axis here, that's January 1st, all the way to the end of December. So the most electrified day, mid to late July. So you got plans around there? Probably not the best for hiking or anything like that. That's generally when our monsoon's in full effect. So the mountains are incredibly electrified. Those storms go off of the mountains, go over the plains where it hits a little bit better of an environment, strengthens up a little bit, continues to develop. So that's the main reason why. Peak monsoon season generally. So time of day. This is the question that I always ask people. Does anybody read Zulu time? Good. We have a higher density of Zulu people here than other places. So Zulu time, Greenwich Mean Time, essentially just the standard format. Used a lot in the military, used almost exclusively in meteorology. So 12Z right now is 6 a.m. So 6 going up to 18Z, that's noon. 0Z is 6 p.m. 6Z is midnight. And then going back down to 11Z, which is 5 a.m. So binning it overnight, evening, afternoon, morning. So the one thing that's really interesting about this, if you look at like 16, 17Z, so this is noon again, 11, 10, you notice the big jump, right, between no lightning and a lot of lightning. That's when thunderstorms really develop over the mountains. That's why they say, you know, get off the peak before, I'd debate even before 11 a.m., but start early, end early, get off the peak. The most electrified time, July 22Z, so what is that? 1, 2, 3, 4 p.m., which makes sense. There's probably thunderstorms over the mountains and over the plains at that point in time. A lot of electricity happening. So these are some of my least favorite slides, to be honest. They're not great, but we got to get through it. So this is what this is a relatively well-built house. A tornado, went over it clearly. This is a before and after photo. The thing to note, this is an interior room that's still standing. The rest of the house is gone. You know, if you're in these interior rooms, chances are you'd likely have a better chance than you were on the outside of that. And this is the tornado pose. Cover your head, cover your neck, have your back facing. So just protect your noggin, right? So this shows, and this is my least favorite one, but I like showing this because of the worst option thing. The best option's not really a true thing. This is created by FEMA, and they're like, yep, have a FEMA safe room, which costs $10,000 of concrete. So it's like, not many people have that. But the thing is to note is just do the best with what you have. If you happen to be in this worst option scenario, if you're in a mobile home, hopefully there's a safe shelter, or if you know that there's thunderstorms that are developing and you're in that area, perhaps try and find a plan of action a little bit earlier on, a place to know that you can go to. This thing, the vehicles, I disagree with this. Like if you're going to be sucked up by a tornado and you're in a vehicle, that's not a good option. You should probably try and find something else. However, you have the full control to turn around and go away from a tornado. So vehicles are a pretty good option in a lot of cases. Just drive away. And this is my favorite one right here, underneath an overpass. See it all the time. But in that movie, I think it was in 2008, Man of Steel, y'all see that Superman movie? There's a moment where, I believe, I haven't seen it, but there's a moment that Superman's dad dies in a tornado, and they're all underneath an overpass. That's where they thought it was safe. It's like Hollywood not truly understanding what's happening here, because under an overpass, it's literally a channel. If you push air from around it into a smaller area, it's going to accelerate more quickly. So the debris that's coming from the tornado is going to accelerate through the underpass, which isn't great, obviously, for getting hit by debris. So if you see that, that's not great. Don't go under an overpass. Go find another place. If you're on the road and say impact is imminent from a tornado, it's actually encouraged to find a ditch. The chances that a tornado goes directly over you are fairly slim. The more dangerous thing, especially if you're out walking around or anything like that, is to go in a little valley where the wind can go over you instead of on you or at you. So all the debris will go over you. So that's actually a safe spot in that situation. Bad options, large open rooms like gymnasiums. You see it all the time on the news. I know back in, what is it, the Joplin tornado, they had some really good footage of an open gym, or a large gymnasium, and it caved on the center of it downwards. You know, some people who might not be informed, some school districts might put kids in there because it's an easy place to put a lot of people. That's not the safe place to go. Less structural integrity at the middle of that gymnasium. Manufactured housing is getting better and better and better, but they're still considered a lower quality of build, therefore they break a little bit more easily. But going to the good options, this is what most people have. Interior room, it's a well-constructed house, or a crawl space, or a basement, someplace that's slightly below ground level. And of course, the best option, the FEMA safe room. The ironic part about this, though, is in Oklahoma, the places I associate the most amount of violent tornadoes with, their geology there is really interesting. It's really hard, and you can't really dig into the ground that easily. So a lot of people have these safe rooms because they need to, interestingly enough. So to beat the dead horse, interior room or the basement. Try not to go to the attic during a tornado. Interesting thing enough, too. How many people have braces on their garage door? Yeah. Garage doors are one of the most susceptible things. If you have a strong, say, wind going directly at your garage, the moment it buckles, it depressurizes and your roof will blow up. It's like, yeah, it happens all the time. So they sell these braces that actually keep this, keep your garage door a little bit more safe and structured, I guess. So one thing to know. Flood safety, already said it. Who raised their hand was? You raised your hand, didn't you? Turn around, don't drown, don't drive through the flood. Your house is right there. I get it. Try and find an alternative way. I don't doubt you either. I don't doubt you.
They had barricades. They didn't barricade that road. This was in Arkansas.
There it is.
Whole state flooded.
Yeah. Gotcha. During a hurricane? During a hurricane?
No.
Oh. That's
Rained
what,
for days and then it got real heavy.
that's why I don't live in Arkansas. But more or less, we don't know what's happening on that road right there. There could have been a culvert right there and it exploded and wiped out the road. In fact, this is that example. This is in Fremont County, actually. So just west of Pueblo there, culvert exploded. That was covered in water once. So if you're trying to drive through, of course you would go into that and go away. So turn around, don't drown. Wildfire safety. Wildfire is, becoming more and more common. The thing is, 98% of wildfires are started by humans. They start by lightning, sure, but that's definitely in the minority. And I'm not even talking like, you can make it controversial, right? You can talk about climate change. This is just fact. Humans create fires where they shouldn't on days that they shouldn't, and then this happens. So let's learn a little bit about, why. So question, what three, I like how the answer's right there. You know? So fuel, oxygen, and ignition. So the fuel and oxygen, that's always there, right? You know, there are times of the year that it's technically a little bit more dry. I like to say that fire season doesn't really ever end anymore, right? Like if you get the right setup, you're gonna have a fire weather day. You know, there are days that, you know, the meteorological conditions are there, but the fuels are too wet, sure. But that's what we talk about when we're talking about fuels. You know, there's a whole bunch of different kind of fuels. There are fine fuels. There's a tree. Heck, if we're in the way, we're even fuels, right? So, but they all dry out at different rates. So stay hydrated, one, I guess. But two, the fine fuels that are over the plains, they dry out much more easily. So if you have a really strong westerly wind, say, like we had today, that dries out your fuels really, really quickly. So that 44 inches of snow that fell over southwest, just southwest of Manitou Springs, that's all gone. Now we're proceeding to dry it out with hot, dry, and windy days. Especially over the plains, this is more of an issue. So if you can remember, I'm not sure if you heard about it, but what, a couple months ago, we had that 1 million acre fire that developed over the Texas Panhandle. Those are really fine fuels that were that grew really, really efficiently due to a lot of precipitation. It grows, it grows, it grows. Then we get dry, turns into just really, really good fuel for fire to spread. Oxygen's everywhere, but the ignition part, that's the part that we can control because 98% of fires are started by us. Not you guys, right? Human beings in general. So how do wildfires spread? Wind, right? Go to the Waldo Canyon fire. It was a small fire at one point in time, but we had thunderstorms develop just south of that fire. And then it did the big run and went to the mountain shadows area, and it pushed, you know, south to north. So winds help direct where it comes from. In the warm season, winds become a little bit more erratic. You know, in the cold season, you can kind of understand where the winds are coming from. Strong, you know, northerly wind kind of day. But wherever thunderstorms develop, say a lightning strike does develop and does start a fire, winds around it will push it in every which way direction. So it really depends on where thunderstorms develop and where the outflow develops and pushes the fire to. So that bottom question is a good one. How do mountains make it worse? Yep. Exactly it. Yep. And we have our diurnal wind fluctuations as well. So in our peak, you know, firefighting periods at night, you get up valley and down valley winds. So at night, during the day, it's up valley, and during the night, it's down valley. So we have that kind of shift in just general fluctuations. So I misspoke a little bit earlier, but during the day, when you're trying to fight it, it's essentially just going to continue to get pushed up the mountain just by natural fluctuations. The mountains breathe here in Colorado. During the day, they inhale. That's why you see all the thunderstorms at night. That's why it's always clear at night, because they exhale. Wind goes down the mountain. So what are we going to do about it? So this is our criteria for critical fire weather conditions. There's the bullet points. Dry fuels. So we work a lot with our partners. We have partners in the BLM, the U.S. Forest Service. Who else does it? I think those are the two main authoritative figures in fuels. But to go out and test the fuels across an area, and they determine if it's critical or not. They let us know. And if they are critical, then if there are meteorological red flag conditions or fire weather conditions that are low relative humidity and strong winds, we'll issue a red flag warning. We had a red flag warning out for today. All those conditions were met for 3 hours. Relative humidity of less than 15%, wind gusts or sustained greater than 25 miles an hour. These are the worst case scenarios, of course. The Waldo Canyon fire, not a great scenario. And then, of course, the Marshall fire. So they're bad in both of their respective ways. Waldo Canyon created a heck of a burn scar afterwards, flooded, and then went into a part of Colorado Springs that obviously had a lot of really big houses, things like that. You know, the winds didn't really help anything at night. When the inversion set up, all that smoke just went down over the city. So really bad for air quality. But yeah, that's probably the worst fire that we've had in, in our area of forecast responsibility. The Marshall fire was a whole other beast. They had a downslope windstorm that day. So you had wind gusts measured of greater than 100 miles an hour. Spark occurred, created a fire, and then went through Boulder County. Not a good scenario. This is what a burn scar looks like from space with an active wildfire ongoing. So clearly to the north, that's where the fire is. You can kind of see where the transport is too, right? So the smoke's going off to the whichever direction that is. I'm going to assume it's west, southwest. But you can see the fire, eating away at the forest there. The other kind of thing to note is the burn scar itself. So why don't we like burn scars very much? Flooding. Yeah. And the reason being is this. If it burns hot enough, it changes the chemical compound of what the soil actually is. Becomes hydrophobic, water phobic, scared. So it no longer wants to infiltrate water. It just turns it all into runoff. And so depending on, what's there, it could be debris flows, mud flows, just flash flooding in general. Yeah, that's why in southern Colorado, wherever there's fire, really in general in the mountainous areas, it becomes an issue because the fire, of course, impacts people's lives. But then the next X amount of years, roughly 5 years, we have to monitor that small area for just light rain showers going over it. Because the lightest of the rain showers, as long as it's producing, around a 1/4 inch initially, not a lot of rain. It could create some flash flooding over an area. And we have to monitor that for quite a while. And then afterwards, like this part, the after fire, 5 years later, 6 years later, that's when all the trees start falling down too. So that's another consideration that we have to have for the long term as well. These are our active burn scars right now. We just retired a couple. The Junkins fire, the Junkins burn scar and the Hayden Pass burn scar located in, Pueblo, Custer, Fremont, Chaffee, and Saguache counties. But now we just have the Spring Creek fire, which developed in 2018. It's getting close to retirement, to be honest. But that's down in Huerfano and Castilla County. And then the other is the Decker fire, which is just south of Salida. Fun fact, I got married in Leadville while this was ongoing. So we're at 10,000 feet looking straight south and seeing all the fire. Thankfully, they got that fire under control pretty quickly. And actually what ended the fire was they ended up getting around, a foot of snow a couple days later. So yeah, this one is still probably our most active burn scar. This has really settled down over the last year, which is great. So snow squalls and blizzards, they're almost the same thing, except the snow squall is on a much shorter time scale. Essentially what a snow squall is blizzard-like conditions over a small period of time along essentially kind of a thunderstorm. It acts the same way as a thunderstorm. If you look at it on a radar, it'll be just this little line that develops and moves over, but it creates, hazardous conditions, especially for people who aren't expecting it, driving. All of a sudden they hit a wall of snow, gusty winds, and rapidly accumulating conditions on the road that create icing. So we issue WIA-based products for these now too. So your phone will go off if we think a snow squall is strong enough and it's heading over a certain area. Blizzards, these are the qualifications. So blowing snow, the requirement is to be 35-mile-an-hour plus winds, and then 1/4 mile visibility or less for 3 hours. Y'all remember the bomb cyclone of 2018? That was 22 hours of blizzard conditions over the Palmer Divide. So you're no strangers to that up here. I think we had one blizzard warning that I don't think panned out very well this year for you all. So emergency alerts and wireless alert systems. This is the thing that I was talking about in the beginning, our thresholds for when your phone's going to be alerted. So the first thing is a base thunderstorm, severe thunderstorm is not going to go to your phone anymore. In fact, a considerable thunderstorm's not going to go to your phone anymore. The one thing I really suggest, and I have it on my phone, is the FEMA app. So for situations that don't go to your phone, because look at this, this is the stuff that goes to your phone: 80-mile-an-hour winds, 2.75-inch hail. That's huge hail. 1-inch hail is damaging. Would you like to know that your car is about to get dented? Because 1-inch hail is the threshold for damage on your car. I do. That's why I have the FEMA app. It's not life-threatening. A 1-inch hailstone's not going to knock you out. A 2.75-inch hailstone probably will, but that 1-inch hailstone's not. But I recommend getting the FEMA app. You can, put your location in it, and it'll give you those kind of sub-severe warnings. You have to put it on the settings, though. It's going to default at that destructive tag there. Change it and say you want, base severe thunderstorms. The app should be relatively easy to figure out, but.
Are these the same criteria for the norm? No weather alerts, no radio weather?
No, those will go over no matter what.
Good.
Yep, that is good. Unless you're in the upper Arkansas River Valley where there's no NOAA weather radio reception, which is a big issue. just don't get caught, right? So anyways, so base 58 mile an hour, gonna say 60 mile an hour in the verbiage, 1-inch hail. WIA, no. Considerable, 70 miles an hour, 1.75-inch hail. No WIA. Destructive, 80 mile an hour, 2.75-inch hail. Yeah, we'll let you know over your phone. Honestly though, it is, we do send these out for just life-threatening kind of situations. So if you're under the 80 mile an hour or 2.75-inch hail, get it. It's gonna hurt. So that's why we send it out to the phones that way. Otherwise, you're just over alerting people. A lot of people get mad, but mainly we're just trying to focus on the things that will kill you. So you can scan it if you want. It's just going to tell you what kind of verbiage goes onto our WIAs. There's been updates, so if you want to learn about the update with like 360 language, we can say more things. We have more amounts of characters that we can send out now, but that's all the information's right there. It's really good for bedtime material. We'll sleep right away. So now we're going to go into the meteorology. This might be a good spot to take a break. In fact, I think it would be. If you want to take like a 3 to 5 minute break, if that's okay. Get everyone jazzed about the severe weather talk that's going to happen. Yeah, so we'll start at 7:28. Any questions in the meantime?
You guys' office at the Pueblo airport?
It's right by the Pueblo airport.
Okay, some picture of like,
You've probably seen me outside ordering a burrito from the burrito guy that comes there. Yeah.
do you guys get
What kind of reports?
pilot reports?
PIREPs. We get them, but we don't really care too much about them because that's a different agency who cares about it. But we do get it, especially for people trying to land, because that's when we care once it gets down to the surface. So if there's like severe turbulence just above or wind shear, then we care. Yes. Do you have affiliation with the airport?
The Pueblo airport?
Yeah.
I heard around there all the time.
Okay.
Yeah.
Gotcha. I'll keep in mind if it stinks that day, you're farting around that day.
How many license plate?
5 or 6 at the office, including myself.
How long have you been down to Pueblo?
8 years.
Okay, then I know. There was an old guy,
Mhm.
some of your friends. They are 40-some-odd years, Pueblo,
Hmm?
just years ago.
Hmm?
You remember?
There's a few people that there's Paul Wolin, there's Chris Price, there's who else retired? Pam, Evenson.
It might be, is that, I think he became a professor.
I'm not sure then. That might have been before my time. Those are the main retirements that I'm aware of.
Okay.
Oh, there's John Kalina. You know John Kalina?
Yeah, I've talked to him on the phone many times.
Sure.
Over many years. Because he was providing micro forecasts
Mm-hmm.
when we were running air search.
Yeah, I mean, you could have got a bunch of different people, I guess, but
Well,
those are the
one guy in
retirements.
particular, because
Randy Gray, that's one of them too.
he often did on the website receipts of forecasts by the different models. But his accuracy in micro forecast, when we really needed it, was phenomenal. And I wouldn't have kept his
Yeah, I mean, to be honest, there's a lot of really good forecasters in the office that qualify for a lot of people, but the retirements, those are the people that retired. One guy passed away, Larry Walrod, Tom Magnuson, of course, the previous WCM retired. Yeah, but if those names don't ring a bell, I'm not sure then.
We're trying to survive. Last time I got
2002? 2013.
yes, but see, that's when I was.
Yeah.
So one of we had to get the
Gotcha.
what the airplane was, people was administrating. They wanted to do so.
Mhm.
And they had a downdraft around 3,500.
Yeah, not great for.
Worse than jumping in an elevator.
Yep.
And we recovered about 100.
That's terrifying.
Well, I just thought it.
Have you? And
So,
repeat that last sentence.
for all those days, the weather service has been a significant support in air search and rescue.
That's great. I hope they use the weather service offices at all the places like that, because we get a lot of calls from search and rescue. Maybe not just air, but all of the above.
Yeah, well, there, where 5 minutes can make a difference between totally. Because we lost an HH-53 officer, didn't treat them in New Mexico because they were a little slow in responding to things. They didn't die.
Yeah. Understood. Yeah, that's why, we're always situationally aware at the weather service. We have to be,
Yeah.
especially in the Mountain West.
Every
Sure. Well, I appreciate the comment.
when they helped me on the plane, when I went to this last, massive bruise. Yeah.
That must have been turbulent. Oh,
Turbulence.
yeah, mountain waves are, yeah.
So have you ever flown the first picture when they discovered, started researching the mountain wave?
Yeah, I've looked at research articles. Yeah, I didn't see those photos.
They had, it was one of the first of the Ottawa, right standing up here.
Yeah.
Oh, by the way, that's where I got my.
Okay. Oh, cool.
Yeah, but they had a picture of doing it for walk, B-25. Why, yeah. And then Oregon Mountain.
Mhm.
And they actually had testing with the like camera by looking at this.
Huh.
And what, some of the parts.
Yeah. Yeah. Pretty fascinating. What's that?
How do you see it?
You don't. It's invisible. Yeah. That's the hardest part is how it is.
I just think of any mission. Where
Yeah.
Okay.
Yep. I appreciate that. All right, folks, we're gonna get going again. If we don't, it could be like 10 o'clock when we get out. All right, everybody, let's get sitting down. We're gonna start up again. And we're gonna talk about thunderstorms and how they develop. All right, I'm gonna go on now. So, what are the ingredients for thunderstorms, ordinary thunderstorms, not necessarily severe thunderstorms, but what are the ingredients for thunderstorms? You've got instability, moisture, and lift. So in Colorado, we have a natural lifting mechanism that's always there. It's the mountains. They're there every day, and that's why we start getting thunderstorms that develop almost every day during our warm season. But the other things that you need are instability. You know that that thing that I tried to do my best at describing a little earlier with the pot and the convection, the bubble, that's the instability portion. So the best setup is when you have dry air aloft, moist air at the surface, because if you have dry air aloft, that air is going to cool more quickly than if it was wet. You know, it's just a thing of physics, right? The specific heat of water is higher than that of dry air. So it's able to cool and heat more efficiently if it's dry. So if you have dry air aloft, once you put that blob of air that I keep talking about, the things that are bubbling at the bottom of the pot upwards, you start going up and you get a really cold air, it accelerates even more quickly. So the more instability, generally speaking, the stronger the thunderstorms will be. And of course, the second one there is the moisture. We have the Gulf of Mexico give our moisture a lot. So that's an ample amount of moisture that we deal with. Anyways, you have to have like the right kind of setup, and you can get all that air coming from the Gulf all the way to southern Colorado. During our monsoon season, we have two different taps of moisture that form over Colorado. We have a tap of moisture that's over the Baja Peninsula there of California going this way. And we also have the tap coming from the east, from the Gulf of Mexico. So if you have those two taps in place, flash flooding like crazy over our mountains and even over our plains. You know, I think what year was it? 2020, what's it now? 2022, 2021. We had a really good monsoon season. We had flash flooding over our mountains almost every day. It was a pretty intense summer. But at any rate, more severe weather-wise, instability, moisture, and lift. So what's instability? Can I summarize it? I probably can't do it again. So cold air, warm air going into cold air and accelerating vertically really quickly. So here's what that looks like. I'm going to go through the life cycle here. So this is an ordinary thunderstorm, towering cumulus stage. This is when air is almost exclusively just going up. And so that blob of air is essentially coming from the ground, going vertical. It reaches the point where the temperature and the dew point temperature are the same, clouds form, and the air keeps going up and up and up and up. So at this point in time, it's still in the development phase, so you're not really getting any rain quite yet. But once you reach the mature stage, you start getting the updrafts and then the downdrafts. Because if you can imagine, you have to force air up, right? So that air, once it gets into the cold atmosphere around it, has to continue to go up until it hits this point right here. Does anybody know what that air is hitting? Yeah, you nailed it. Thank you. So what do you say? That's the tropopause. It's the boundary between the troposphere and the stratosphere. That's the first time I've ever heard that at a spotter talk. Well done. So directly above it is the stratosphere. The stratosphere holds all of our greenhouse gases and absorbs a lot of heat. So therefore, once you get to that boundary between the relatively cold troposphere, and then you go up to the warmer stratosphere, there's a natural barrier called the tropopause. And that's what you're seeing right there. Thank you. That's awesome. I love it. But anyways, you can start seeing once you hit the air, once the air hits that tropopause, it has to spread out. It's like hitting a ceiling, so it spreads out and it creates anvils. But also in that spreading out, you start getting a bunch of phase changes and temperature differences that occur at that level. So let's just say you start evaporating air at a certain spot or something, the air gets more cold than the air around it, so then it has to start going downward. So if you think about it, it's just like a big kind of circuit. Goes up, evaporation, cooling, goes down, et cetera, et cetera, et cetera. So in an ordinary life cycle, these things kind of dissipate really quickly. And this is what the dissipation stage looks like. So this once was an anvil on the image there, and it's thunderstorms now becoming outflow dominant. So there's no more air getting sucked up and going vertical. The air's just going downward. You can't sustain a thunderstorm if the air's only going down. So that's what you see there. Air going down, air spreading at the surface, similar to the tropopause. You know, it has to hit this boundary here, and then it spreads out. You see this a lot in days that say have a lot of instability, but not a lot of wind shear, which is, spoiler alert, the fourth ingredient for severe thunderstorms. But they develop, they die, and you start seeing these little orphan anvils form and, you know, spread east with time. It's actually quite pretty. So up, up, down, down, essentially is the life cycle. The thing is, though, in southern Colorado, this can actually cause issues. So there might just be ordinary thunderstorms, but once you get to, say, like this stage right here, or even this stage, we have such a dry air mass over Colorado that there's a lot of evaporation. When you evaporate air, it goes from water vapor, it goes back to gas, and during that phase change, it actually absorbs heat and makes it cold around it. It's just thermodynamics, right? And during that phase change, you're actually cooling the air around you. And therefore, if you're getting cold air in a warm environment, it becomes dense, it accelerates down to the surface. 2022, we had 8 people die on Lake Pueblo State Park on the reservoirs there. You know, some issues were associated with like not wearing a life vest or something like that, or personal flotation device. But the other half was these. So notorious in southern Colorado, so notorious in dry atmospheres. They have thunderstorms that develop aloft, create gusty downdrafts. You know, in this case right there, that's over Colorado, it could be a 60-mile-an-hour wind. The horrible part, though, is that we can't see that at all on radar. It looks like a green little blob, and there are thousands of them that form over our area that we forecast for. Which one of those blobs is creating 60-mile-an-hour winds? We don't know. We really don't know. So the best way to do it is to message information like this probabilistically and start talking about Well, between this time and this time is the best chance for wind gusts going to be greater than 60 miles an hour. And we're doing that with Lake Pueblo. We have a dedicated website for them that gives a probabilistic forecast for them. But it's a huge issue. Even ordinary thunderstorms can cause life-threatening situations. The lake's big, right? Creates white caps, capsizes the boat. You're not wearing a device. It's clearly dangerous. So multi-cell thunderstorms are another form of, kind of ordinary thunderstorms, but they can last a little bit longer. They produce a couple more different hazards. And so in this case right here, you can start seeing different cells develop, because when you have the right situations, a thunderstorm can kind of sustain itself for a while. So you get updrafts initially, but like I was saying, you get updrafts and the downdrafts. The downdrafts are cold air, relatively speaking. And that cold air is more dense than the air around it. So once it starts hitting the ground here, it creates a gust front. This is cold air behind this front. Essentially, it's a cold front, if you think about it that way. But as that cold front propagates to whatever direction that is, I'm going to call it west, the air's going to go over that gust front, and then that's the lifting mechanism. Then the air starts going, that blob of air starts going into the colder atmosphere and has to convect again. It has to go up. And this is like a vicious cycle. It just happens and happens and happens until it reaches the part of the atmosphere that's not conducive for sustaining itself anymore. Let's say at this point down here, there's a lot less instability. So when that gust front comes through, maybe the cell's not going to develop. But if the atmosphere is still conducive, i.e. unstable, it'll just continue to develop. So let's say all this complex of storm is moving, again, let's say this way to the west. That's when you start getting different kind of hazards, like flash flooding hazards. You got a thunderstorm develop over an area, then it develops over again and again and again. That's a flash flooding risk. So, yeah, these are more likely to, instead of just being like a pop and drop kind of thunderstorm, since they're kind of sustaining themselves a little bit, there's a higher chance for gustier winds, maybe a little bit bigger hail, and a longer life cycle. So this is what it looks like, though. This is a really, really good example of a multi-cell thunderstorm. This shows me that it's probably not the worst day. The instability is probably not very high, because none of this has really reached the troposphere, or the tropopause, I mean. So you've got one updraft, which probably created the second updraft, which if you analyze it, looks like this updraft is probably in a little bit more unstable environment because of how high the cloud's reaching. But then that thunderstorm created another gust front, which created this updraft, which, well, we'll see what happens, I suppose. But so thunderstorms sustain themselves. Yeah, question in the back. So that's exactly what it is. Yes. So it's essentially just trying to get air. I'm trying to summarize the question for people who are virtual. The question was what essentially is what the mechanism is to create the next thunderstorm, right? In a way, like. Yeah, okay. So the question being, essentially what's going to help create the next thunderstorm? The downdraft from that thunderstorm is creating essentially a wedge that helps push air that's in the warmer environment up a little bit. And then I'm just restating what I already said. Sorry about that. But yeah, so essentially what you're saying is true. The cold front acts like a wedge and it's going to force air up. And the way that you're describing it too, calling it energy, is very much true. There's a parameter that we have in meteorology called CAPE, convective available potential energy. Keyword potential energy. It's a bunch of energy that's essentially just there because the atmosphere aloft is dry and cold. And if you get some sort of blob of warm air into that atmosphere, it's going to go up very, very fast. And so when we do our forecasting, we look at CAPE, which is analyzed by models and observation. But the higher the amount, say 2,500 joules per kilogram of CAPE, that's very high. So that's when you can start seeing the strongest thunderstorms. So the term energy that you use is a really good way to look at it. There's a lot of potential energy there. But yeah, these thunderstorms create their own environment. And even at some points in time, that gust front is colder and more moist than the air around it. So it actually creates a more unstable environment because there's more moisture to work with at the surface due to a downdraft. So they seriously just, they can create their own environment and propagate it along for as long as they need until they reach an environment that has less instability, or maybe even night falls and the instability goes away. A whole other water bottle? I don't know who brought this up, but thank you. Thanks, Bob. Oh, that bugs me. That S is not where it should be. It's a thunderstorm S instead of thunderstorms. So the ingredients for a severe thunderstorm, it's all the same thing, except shear is the big component. The shear is essentially where the wind goes from the surface to aloft. So a really good, I guess, wind regime in the upper and lower atmosphere is let's just say in Colorado, southeasterly winds at the surface, northwesterly winds aloft. The northwesterly winds aloft are likely bringing in dry air from the northwest. The southeasterly winds are bringing in more warm, moist air from the Gulf of Mexico, and they're coming in at different directions. So the only thing you need to do is turn those different directions horizontally. So switch it from a vertical to a horizontal, and then get a thunderstorm to develop underneath it and push the air up. That's when you start seeing your rotating thunderstorms. So the air is not naturally just rotating out there, right? The air is coming from different directions, and then you have to change and tilt the way that air is flowing to more of a vertically stacked kind of way through the process of thunderstorms. And then the air will go around like that, essentially, because once you start getting thunderstorms, you're starting to lift air in the center, which is a low pressure system, which creates circulations. And anyway, I'll show you a schematic about it. So here are the thunderstorm types, schematics incoming, but more to less common. So less frequent. Oh my goodness. More common to less common, increasing risk or threat as you get up into these different pictures. So this is a single cell thunderstorm that we talked about, multi-cell. This is a wind-driven kind of situation, a squall line that develops with a shelf cloud. And then this is, you know, like the mothership, right? The rotating supercell thunderstorm that has all of the hazards that you could ever want in a severe thunderstorm: tornado, wind, hail, lightning, all that stuff. But this also is a proxy of the amount of wind shear. So in this case right here, there's likely not a lot of wind shear, a little bit more wind shear, and then a nice balance of instability and wind shear. Here's the schematic a little bit. So at the surface here, you can see that there's a tornado at the bottom. The wall cloud's directly underneath it. We've talked about wall clouds a little bit. That's where the action is of the thunderstorm. The one thing to note is the clearing right around that wall cloud, especially in Colorado. There's a lot of dry air and yes, more moist air interacting, but very, very visible. The areas that you're seeing over here, that's where the downdraft is, and that's essentially where the hail and the wind and the rain are going to fall. That's not the wind. The hail and the rain are going to go. So if you think about it this way, air going up, going up, going up. This is the tropopause once again. Sometimes the updraft is so strong that it goes into the stratosphere, which you get these overshooting tops. And then once it tries to stabilize itself, then it goes right back down, creating wind, hail, and all that other stuff on the backside. Another schematic. The one thing to note is, like, magnitude is a thing. Like low pressure systems, right? They have cold fronts, warm fronts, all that stuff. But you can shrink that down. Every thunderstorm's its own little low pressure system that forms. So when you start seeing these, this looks like a cold front, the stuff that you see on television, right? That's a cold front. The air on this side is colder and it's advancing this way. So that's a front of cold air going into, you know, warm air. Go over here, this is a stationary front. And on this side, there's another cold front. If you look at it this way, think of this like, you know, if you're watching the news or something like that, the big L that's on the TV. This would be a big L on, like I say, a continental sized low pressure system, big L. But in this case, it's very small. It's just all the way down to, you know, tornadic levels, because the low pressure system is essentially the tornado. But associated with that, these acronyms, which I'm not going to go too into detail about, have different barriers. So this is the rear flank downdraft, which is associated with cold air from the thunderstorm that hits the surface, spreads out, wraps around. This is the updraft. Remember that first image that I showed you where I said you could really see where the inflow is coming from? Well, this is the updraft and the inflow. That beaver tail, the clouds that are coming from the wall cloud, will sometimes create a cloud very long that goes to the center of where that low pressure center is, the tornado. Sometimes you can see that. This is the forward flank downdraft. This is where all of your hail is going to be and your heavy rains. Notably, the closer you are to the clearing, let me go back here, the closer you are to where it's clear, that's where the heavier, the larger hailstones are going to fall. You know, matter of physics, right? The bigger the hailstone, the heavier it is, the easier it is going to fall. So if you're close to this, that's not good, because that's where the biggest hailstones are going to fall. So this is kind of like a perspective kind of thing. Like, what would a thunderstorm look like on various portions of where you're located and looking at the thunderstorm? So the first place, this one right here on the bottom left, that is where you want to be if you're observing a tornado. Generally speaking, the tornado, the supercell thunderstorm, travels where the outflow is, where the downdraft is. So this storm is going to primarily be moving to the north. Let's call this, you know, never eat shredded wheat northeast, right? So looking south to the north, you can see the wall cloud, potentially a tornado eventually, perhaps. If you look at it this way, looking towards the outflow boundaries, you can start seeing a shelf cloud form. So again, notice how it's dark and ominous right here. You don't really know what's happening back there. If you go to the upper right-hand image, this is the bona fide shelf cloud, likely going to be strong winds, heavy rain. That's soon to come, but you're looking this way, looking to the west, southwest, perhaps. You can't see anything there, right? So how are you supposed to know that there's a tornado there if you can't directly see it? So the point being, if you're out observing, try and be mindful of where you are in proximity to where the storm is. If it looks dark and ominous, perhaps take a look at your radar, or perhaps try and find a little bit more information about it. You can call the weather service whenever you'd like and tell us where you're at and ask questions. But in this case, you can't see that this is right there. You just can't see it. There's too much rain, there's too much hail, there's too much precipitance in the way. So if you look on your radar app, I mean, this kind of looks like the reflectivity in general. You start seeing things that look like this, you'd really want to not be in this kind of area. You want to be south, and preferably south and west when you're observing it. So the really strong storms kind of look like this. So this is your base right here. You can kind of see if there's a cut right there. This whole thing is rotating. This is a mesocyclone. But the thing to note is that the updraft is tilted, and this is indicative of really strong wind shear. Again, wind shear is kind of synonymous with strong to severe thunderstorms. It's not always the case. Sometimes the air is too wind sheared that it can't keep up with the instability, but that's for a whole different kind of topic to discuss that we're not going to go into today. But in this case, this thunderstorm is tilted. That's going to be a strong storm. So if you start observing these things, start seeing tilted thunderstorms, probably severe underneath that thing. This is a mesocyclone. The wall clouds at the base here. In Colorado, this happens more often than not. You start seeing really well-defined mesocyclones. So this whole thing, you're observing it, would be rotating counterclockwise or cyclonic in the northern hemisphere. You can see the striations of it. So different little layers, stronger rotation maybe right here, stronger rotation above. You can start really seeing the striations due to, well, it's essentially just rotating at different velocities, therefore it creates different layers. Again, notice the rain-free base more or less, and then the rain on the forward flank downdraft side. And again, rain-free base. Large hail, small hail, rain. Just physics, heavier stuff falls more quickly. So tornadoes. We're going to talk about the different types of tornadoes on the EF scale, land spouts a little bit. But weak tornadoes, we have a lot of them. We have a lot of them in even El Paso County at times. But these are just really weak thunderstorms. 92% of the tornadoes that develop in southern Colorado are EF0 or EF1. Some of them are EFUs. I'm not trying to see or anything by saying that, but it's EF unknowns, right? So they don't hit anything. Part of my job as the warning coordination meteorologist is to go to places that get hit by tornadoes, analyze the structural integrity of the building that was hit, and then give it a EF scale rating. We had an EF3 located just south of Lamar last year. It hit a farm, so I was out there analyzing the structural integrity. We gave it like 156 mile-an-hour wind gusts, which is the border between EF3 and EF4. But a lot of these are really small. They don't last very long. They could obviously still be damaging, of course, but these are kind of hard to see on radar. Again, another reason why we need spotters. EF2s and EF3s are not common at all. 5% of Colorado tornadoes are EF2 or EF3. They last longer. They're generally associated with more organized thunderstorms that create their own environment. They're easy to see on radar at this point. One, because the rotation has to be strong in order for it to get this strong, or get this big, or perhaps it's lofted some debris, and so you can start seeing some potentially dust or crop or, God forbid, a house on the radar. These are generally, pretty good. A lot of spotters see this, of course, because they're so visible. And there's a bunch of storm chasers that are likely going to be storm chasing on this day. We've never had an EF4 to EF5 tornado in Colorado. Should be thankful about that, because these are the storms that get really, really big. EF5 starts at 200 miles an hour. It just goes up from there. There's not an EF6. We haven't had an EF5 in the States since like 2008, I want to say. You're on it. Yes, that was in Moore, right? Yeah. Okay. So he's get up here and teach this class. I'm telling you, you're awesome. They're long track supercells and long track thunderstorms tornadoes at this point in time. Again, these storms have the perfect balance of cape or instability and wind shear that they just keep creating their own environment that lasts longer and longer and longer and longer. So 1 to 2 hour lifespans, wind speeds greater than 200 miles an hour. Non-mesocyclone tornadoes are very common in Colorado. They're just little spin-ups, right? You have at the surface a boundary of air coming from one direction and air coming from the other direction. A thunderstorm develops overhead. It tilts that, becomes vertical, and starts spinning. The thing is, though, you need to have a connection between a thunderstorm base and the ground for it to be a land spout or a non-mesocyclone tornado. In this case, this is a vortex tube of tornadoes. So there's this long line, a boundary right here. This is a real picture. There's a long line of air coming one direction and air going from a different direction, and each individual updrafts are creating a little spin up. These are not supercell tornadoes, so you're not going to be seeing a mesocyclone associated with these things, just connection from the cloud base down to the surface. We have gustnadoes too. There's a gustnado back in 2021 that developed right over Pueblo West High School. Strong winds, not technically a tornado, but it's just the surface, essentially that same circulation at the surface, and the thermals rising a little bit. It's not associated with a thunderstorm. It's just a brief little spin up due to air coming from one direction to another direction, and a little thermal that's going up in the atmosphere. So you can see these on, warm days in the San Luis Valley, for example. To go to the center of the valley there's just this natural barrier of air coming down from one side of the mountains and the other side of the mountains into the center of the valley, and it just heats up. And then you get little thermals that come up to create little dust storms or dust devils or gustnadoes. Microbursts. These are terrifying. People, I believe they discovered these mainly from accidentally flying into one of them. I believe it was in Denver that was the first one. Or was it Fort Worth? Fort Worth. Yep. Yep. You know. Fort Worth. So there's a couple different kinds of bursts, I guess. There's microbursts and macrobursts, purely essentially how wide the area of downdraft is. So microbursts impacts a small area, less than 2.5 miles in diameter. Macroburst is 2.5 miles or greater. But you can get really strong winds out of this, 60, 100 mile an hour winds, perhaps even stronger. So dry and wet, as you can imagine. One of them looks like there's rain falling down, one of them doesn't. But in Colorado, we primarily have dry microbursts. Occasionally we have wet microbursts. Here's kind of the process, kind of what they're called, the contact stage, the outburst stage, and the cushion stage. So essentially, contact, outburst, cushion. Cushion means that the curl continues to accelerate, but it's moving further out. So as you can imagine, the point that will have the strongest winds are essentially right where it hits first, and then it's forced to spread out around radially around the microburst or the burst of whatever it is. But as time continues and it spreads out the surface area of it, whatever it's impacting gets spread out a little bit more. The winds decrease as you get away from the point of touchdown. So a wet microburst, this is actually looking south from our office a while back, I believe. But you can just see the microburst, right? This is a wet one. So as it hits the surface here, start seeing those curls. Those are the areas of where the strongest winds are. And then as it goes outward, kind of just spreads. That's dust, more or less, at this point in time. But the winds are going to be a lot weaker here than they are right there. No, it's really hard to. You can see the green echoes on radar, but which one creates the 60 mile an hour winds? We might be able to see the wet microbursts a little bit better because there's more moisture associated, therefore more particulates.
Radiation, so how do they avoid it?
Yep. It's a good question. You can navigate through the blobs of green, but on days that, or maybe you're even higher than what they are. I guess it's for like local aviation. If you're in the lower atmosphere, it becomes more of an issue. A lot of these things, especially the dry microbursts, don't get very high. So perhaps you can fly above it. I'm not really sure. I'm not a pilot. Dry microbursts. This is the holy grail of microbursts. This is a Great Sand Dunes National Park and Preserve. That's the holy grail. Just a downdraft going over a big pile of sand. Remarkable. But anyways, you can see right here. There's an associated downburst or microburst associated right here. There's no rain hitting the ground, but the things that you can see are the dust that's lofted on the eastern plains. Same with here. You can create these dust storm kind of things. Anybody know the actual name of a dust storm? You're close. Haboob. Yep. So that's a haboob. That's the best haboob over the Great Sand Dunes National Park and Preserve. But yeah, these are things that, the precipitation is not reaching the surface. It's all invisible, which is a big problem for aviators. This is a shelf cloud and straight line winds. So this air is, the motion of this cloud is following the leading edge. This is like a cold front kind of scenario. There's a downdraft occurring behind the scenes. There's a boundary, a cold front or a gust front created right here that goes from the surface all the way up into the cloud. Air gets sucked into the storm. So this barrier right here, there's that line, that's air going into the thunderstorm and feeding it. The air will continue to propagate towards wherever this is pointing. So the one thing to note here is the direction. The wall clouds or the supercell thunderstorms, the air is going to move towards where the downdraft is, or the rain or the hail. The shelf cloud is going to follow the direction of where it's pointed. And it's pointing away from the rain. All right, we're making good progress. We're going to start doing the reporting portion of it. So, question for you. When do you report these kind of hazards? Or say hail size, when do you report it? You go out right away and get hit by 1.5-inch hail? I hope not. If you did, maybe you hope you have a hard hat, but we do not recommend going out during the thunderstorm, getting the biggest hailstone and reporting it to us, or being like this guy and saying there's a flash flood occurring at a certain spot. It's not that dire. The 3 C's of emergency communication. I like this slide a lot because, I don't know, I'll speak for myself when I talk about this. When I see a thunderstorm, I get really excited. The adrenaline starts pumping. I'm excited. But conversely, if I'm on the operations floor and I'm issuing severe thunderstorm warnings or tornado warnings, I'm also quite excited. It's exciting stuff to try and figure out where to put the polygon, talk about the hazards, and do that, and try to do it to the best of your ability, because we're trying to save lives, protect property. That's our mission at the National Weather Service. So on both ends, this is hard to do in practice, I know, but clear, concise, and calm. I know that your car just got 1.5-inch hail, 3-inch hail, whatever it is. I don't care about your car. I'm sorry. I want to know the information so I can get back to my warning operation. So when you call and you see something excited, you see 1-inch hailstone, a 3-inch hailstone, you got to cut out the jargon. I'll cut out the jargon. Let's just make this a really quick, calm, and concise conversation. If you want to call afterwards when the thunderstorm's done, I'll talk about it all day. But at the point of when we're in operations, we really want to get the information, get it sent out, etc. The same can be really said about like the, our ham net that we have. If we're asking for, say, no more reports of less than 1-inch hail, unless there's a special circumstance where it looks like a really strong storm and you're getting P's, that's good information for us to know. However, like, let's keep it 1 inch or greater or things like that. So following the ham net operator, it's important. So listen, clear, concise, and calm. Here's a good example of how to report weather, who you are, the exact location. If you have your Latin lawn on you, that's great. If you don't, things that are common around you. You can have, you're on I-25, you start seeing something. What exit are you on? What mile marker are you on? If you're in the middle of the, I don't know, let's say, what's my favorite place in Springs? In-N-Out. Say you're by In-N-Out Burger. Oh yeah, there's some cups there. Say you're by In-N-Out Burger, you're like, I'm by In-N-Out. I'll know exactly where you are. We can Google those kind of things. We can find you really quickly. What do you see? Describe it, but be brief. Got a wall cloud to the northeast of me. Got hailstones that are 2 inches. Where did you see it? I've already talked about that, but when did it happen? This is really important for us. When you start seeing these things, take a note. Whenever you tell your time on your smartphone, your watch, take a note about it. Let us know the exact time that you see it. This helps us do verification. It makes us accountable if we're doing a good job. If we should have had a severe thunderstorm warning last longer, it's important to us. It also aligns where the reflectivity is and your location with the time. So if it doesn't line up, then it doesn't really make any sense, right? You can have a severe thunderstorm, at least on radar, that looks like it, located in a certain spot. You're right here, and you don't know the time. It doesn't line up. So that's when we start questioning things. Like, is that really a valid thing? Et cetera, et cetera, et cetera. Or just be honest, like, it happened around this time. And then we can co-locate it. But just take a note about the time. So hail, we care about penny-sized hail and more. Again, this is the caveat that I want to talk about, though. If you have a radar app and you're looking at it and it looks like there's a lot of purple on that, and we have a warning out for 1 to 2 inch or whatever amount of hail, and you're actually only seeing BBs or Ps, that's really good information, because if it looks severe and it's not, we do want to know that. There's this interesting phenomena that happens in some thunderstorms that it's incredibly reflective, because it's a lot of small hail that's covered in water. So it's like kind of melting a little bit. So when the wave of radiation refracts and reflects off of it, that value is going to be very strong, just like big hail. So that's good information to know. We should, as warning forecasters, we have different kinds of products that we can look at to help determine that. So that shouldn't be an issue, but sometimes it is. So penny size or larger. And one thing, do not call in and say that you have marble sized hail. If I hear that one more time, what is it? Is it the shooter? Or is it the, yeah, you know what I'm talking about. Use it in relative to coins or these kinds of things over here. The other one is hen eggs. I've seen some pretty big hen eggs and some small hen eggs, right? Just say lime instead of that. What if it's a key lime? I don't know. That's when you just say it's 2 inches. So at the end of it, we're going to give you, of course, the password to the website that we'll go over, but you're going to get a hail card. On the back of that hail card, you get a lot of information. We still have a 1-800 number, which is kind of fun, but this is our local number. It goes to the same spot, 719, of course, 948-3838. Tells you a little bit who, where, direction, what, when, all that good stuff. But I have one in my wallet right now. It's laminated. It's always good to be laminated. You're measuring hail that's wet, so you don't want to ruin that hail card. Damaging winds. So how many people can go out there, lick their finger and go like this, be like, it's about 58 miles an hour. I can't. And I also don't have an anemometer on me, generally speaking. So when you call in and say, the winds are whipping, I don't know, I'm going to say it's about 65 miles an hour. I don't believe you. I'm sorry. You have all the experience in the world. I get it, but it's, yeah. The things that we do want to know, unless you have that pocket anemometer on you, is essentially damage, right? So start explaining the types of damage that you're seeing. You got a downed tree or a downed limb. Don't go up to it. This could fall, one thing, but just give us a little estimate about how big the branch is or the limb that fell. Is the tree rotting? All of that will make the tree fall a little bit easier or harder. That's good to know. So tornado versus straight line wind damage. So this is an example of what straight line wind damage. Notice how all the trees are more or less uniform, going in one direction. This is from Pikes Peak tornado of last year. There's branches over here, limbs over here, trees over here, trees over here. They're all in different directions. So we can decipher the difference between the two. Sometimes we have drones that go over that can give us a really good aerial kind of coverage of it. Sometimes we just go out. We'll generally go out and look at it, but we can determine the difference between the two. So we want to know about rotating wall clouds or funnel clouds, both. So if you see one of these guys when you're out and about, we want to know about it. It's really important to know because on radar, this is going to look like it's spinning like a top. It's good to know that it's not creating a tornado yet. So that base right there that you're not seeing anything, that's reportable. A funnel cloud, something that's not quite hitting the surface, we want to know about that as well. These are the kinds of things that you call us on the phone about, or we're monitoring the ham networks as well. So this is the prime example of what a tornado looks like when the condensation funnel does not hit the surface, but there's debris. So the funnel stops right here, but it's still creating debris. That's a tornado. This one's very far away. I don't know if we can determine if that's a tornado or not. It's likely a tornado. There's a kind of a rule. If it's 3/4 of the way down, you can call it a tornado. Flash flooding. So once again, turn around, don't drown because you don't know what's underneath it. But it's really good to get like things that are referenceable. Like referenceable? Let me just make up words up here. Some things that you can reference to. So if that's your like your local neighborhood stop sign, you're familiar with it, you can take an estimate. We don't want you to go in the water at all with a ruler. It's not worth it. You just say that it's flooding. So yeah, you know, one thing to note too, like wheels on a car. Say you have, I don't know, 2017 Subaru Forester. That's what I have. It's in the middle of some water. You can tell us the make and model of the car, and we can do the internet has a lot of information. You don't have to go in and measure it. Say it's about halfway up the wheel on a 2000 whatever. You don't have to be specific. A Subaru Forester. We can get the idea of how deep the water is. Snow. How to report it. You guys had a lot of snow up here, I hear, right? How did you guys measure 40 some 30 some inches of snow? Did any of you? What's that?
Yardstick.
Yardstick. I had some people like they sent reports of like their dog, like it's about 5 corgis tall. That's one way. But more or less, we do like up-to-date reports as the storm progresses. So if you have an inch and then get another couple inches, keep letting us know. We do like that information. It gives us some, ground truth about what's happening. Generally speaking, a lot of people like to call in the morning, which makes a lot of sense. We're not all shift workers and working overnight, and we sleep. So like around 7 a.m., that's when you get a really big rush of people calling in. But it's really more or less whenever you feel like giving us an update. We'll really appreciate it. The other thing, snowboards are really good. If you do like 6 hourly observations, you can have 2 snowboards, one for storm total snow and one for every 6 hours. That's what we do at the weather service. Essentially, it's just like a little board that you can put on top of the snow and it accumulates on it and you can measure on it. The other thing, ice, any ice. Ice is dangerous. I don't like messing around with ice. So if you see any ice or it's slippery, let us know. We might issue a winter weather advisory if it's bad enough, maybe a winter storm warning. We're kind of expecting these kinds of things. Look at this. You can get a ruler, 87 cents on Amazon. You want a wood one, $2.22. That's a yardstick too. So, measuring devices are pretty cheap. The one thing where it gets a little bit more complicated, again, is our snowboard. It could be a lot of different products, but the main thing is white. When it's not white, say it's like black or something, it can absorb heat really well. The albedo of that is much higher than if it's white. So if you want to get a true measurement, having a white board on the ground will help the melting. So we don't want it to melt. We want a true measurement. Let's see. A flag, reflective marker. That's just if you have a snowboard. The idea of a snowboard is it being covered in snow. It's really easy to lose if you don't have a flag by it, believe it or not. And then the last thing, if you want to be the creme de la creme of snowfall observation, folks, is getting a standard 4-inch rain gauge, taking the tube that's in the middle of it out, and then you can melt it down and actually get the moisture content in it. Our 10-to-1 snow ratios, 13, 14, 20, I've heard up to 40-to-1 snow ratios. That's how people measure those things. So can I just measure on my patio? Sometimes, I think we like to say like a 2x2 is essentially the minimum requirement, because if it's any narrower, then it's easily start falling off once it gets too tall or something like that. The other issue of measuring on your deck is you got a lot of weird wind funnels or trajectories around your house. Generally, a patio is pretty close, your deck's close to your house, so wind is going to come from a weird direction. Might not be the most representative. The second question is what I suggested a little bit more. Will I always measure snowfall in the same spot? No, we encourage you not to actually. We want you to go around with your yardstick, measure here, go over here, measure here, over there. How many times you want to do it, calculate it, find the average, and then send us that report. Power Divide gets windy, so there's a lot of drifting. Sometimes, it's not the easiest, but just find a good average of what you find. So submitting a report, we want a direct call if it's life-threatening. If it's not, you can use a whole bunch of other things. And we monitor ham radio. So if it's life-threatening on there, we'll probably have you, going in our office. So yes, that one can go over there too. We have an online form on our website. We have Twitter or X or whatever it's called, Facebook, we have email. Kind of have an Instagram, but we don't really use that, so don't use Instagram. You can call us, what you witnessed, where, and the time. That's our social media handles. We're constantly monitoring this. Twitter and X, that's one that we monitor quite a bit because there's a whole weather community associated with that. Yeah, question in the back.
Monitor particular repeaters or frequencies.
Yeah. Yeah, I think it's on the next slide. Great question. But yeah, these are these are repeaters that we follow. Generally, just the two. Yeah,
Actually, that's.
is it wrong?
Yes.
Yeah.
I'm terrible.
Yeah, the main repeater we use is the CMRG 147.34, 107.2. Now, 143.7, we don't have coverage we can use for this. I'm saying, if you rinse all that shit, use the 1%.
Can you repeat that louder so I can change it in the slide?
147.34.
47.
I think that's it. It says,
We have it at our office. This is just in the slide deck. We're monitoring the right one.
107.3 is the top.
Terrible. 107.2.
Right.
Okay.
We always repeat that. Like this.
Okay. Now that I've embarrassed myself, I'm just gonna go forward.
Both of those repeaters?
Yes and no. We have multiple radios in the office. It depends on where the severe weather is. So a lot of the times it's gonna be over Pikes Peak, then over Pueblo West. Sometimes it's over Pueblo West, so we'll just have that one on. But if we're not answering, you can always give us a phone call and we can start listening again too. So.
You still use anything?
Yes, it's not supported anymore, and it hasn't been supported for a long time. But every time you use anything, it goes into our system, and we can see it. It's a good question. You can always just email us too, nws.pueblo@noaa.gov. So this is the last portion, and we're probably like 10, 15 away from being, and you can go on and have your freedom back. But this is spotter simulation. This is the interactive part. So we're going to ask you questions. Remember, who, what, when, where. So simulation 1. Thunderstorms have been rolling through the area all afternoon, but then you start to hear the sounds of a loud impact on your roof. Practicing good weather safety, you wait until the sounds have stopped before walking outside. Where do you find these? Are those reportable?
Yes.
Yes, they are. What else are you going to tell me about it, though? I'm glad. Yes. When it started. What else are you going to tell me? I just more or less care about the big one. Location, when it started, location. What else?
Well, who you are.
Yep. It's good to know. Tell us your spotters. We'll believe you. I mean, size. Yep. Okay. Yes, so long as the hail meets the size requirement. Again, remember penny size, generally speaking, but if it's a lot of really small hail that's accumulating, let us know about that too. So the last question, which we already did answer a little bit earlier, hail isn't always an easily measured shape. So how do we decide what to measure if different sizes and shapes are falling? So what kind of hailstone are you going to be grabbing first off? The biggest one. Yep. And how are you going to measure it? The widest part. Perfect. All right. So you guys nailed all that. So simulation 2, you're aware of the potential for severe weather today and already see some strong thunderstorms popping up in your area during the afternoon. You check your favorite radar software app and see the following images. What's your favorite radar app? Do people have one, or is it just me? Love it. It's music to my ears. There's radar scope is really good. Fickle radar is really good. The other ones, they're okay. So you start seeing this. This should look familiar, but this is from the beginning of the slide deck. But this is a supercell thunderstorm. What does it mean? See the little hook right there? Large hail, air going from this direction. They're going to this direction, so green towards the radar, red away, confer rotation. So, by the way, this, like I'm young, right? I'm 33. but the guy who made this is in his 20s. There's a differential. Like, I don't talk like that. Anyway, that's spooky, guys. All right, right? Better keep an eye out. Since you don't hear any thunder at the moment, you decide to take a peek outside. For the sake of the scenario, let's pretend that you're visiting your BFF on the south side of La Junta. Here's what you see. All right. You and your BFF, what do you say? How do you report this?
The water tower's on fire.
There might be torn. Why just might? Can't see the ground. Also, what else are you going to report? That's a proper funnel.
Well, you're gonna basically try to approximate the direction and the distance from where you are to that.
How far away do you think that is?
You know,
So that second part, I like what you're saying, besides the estimating the distance. That's probably like 60 miles away. Who knows? I don't know. But that's very far away. That's way far away from La Junta. That's the only thing to note about this one. But yes, the orientation though, where you're at, where you're looking towards, what you're seeing. So you could try and estimate, but looking at radar, we'll probably have a good idea about where it's at.
you were looking at the radar and know your location, you can somewhat estimate the
Yeah.
distance.
And you can do that on radar scope too. There's actually a function that you can get the distance. So yeah, you do that. So let's say the storm is to your east and moving to the north-ish, I guess. So these are the kinds of things that you'd be reporting, like your location, you're on La Junta. Is there anything that's kind of in this image notable? Like, I don't know what bush number 5 looks like. But you see that there's a, road right here, maybe some markings. But again, at this case right here, we just want to know that you're seeing a funnel and where you're seeing. We can probably see this on radar. That's the thing to note. Of course, what's the one thing? Time? Let me know the time when you call in. So, yes, what do you say? Name of the spotter. Where? I'm on the south side of La Junta looking east. When? Now or when the hazard sought? Sometimes people don't call right away, but if you take a note of it, call us later, let us know the time. And I'm seeing a funnel cloud to my east, lowered from the base of the cloud, and it's moving north-northeast. This is the important part. I can't see the ground. So it's important because we don't know if that's actually a tornado or not. But, it's all semantics. You got a funnel. In that case, we probably have a tornado warning on it, but we're not going to say that it's actually a tornado in our verbiage. Simulation 3. It's been raining. Dawning's spelled wrong. It's been raining hard all day today, but you have errands to run. Donning your favorite raincoat. You drive into town and finish your shopping, but on your way home, has anybody been to Alamosa, downtown Alamosa? It doesn't look like that. There's not dunks in Alamosa. So that's not Alamosa. But what would you report on this? Street flooding? How deep is it? Yeah, look at that. There's a C-class right there, Mercedes-Benz C-class. It's roughly up the entire wheel, I suppose. So we can assume that it's deep. We don't care exactly how deep. The definition for flash flooding is 6 inches, but please don't go in and measure 6 inches. It'd say it's halfway up a car or halfway up a Mercedes-Benz C-class. We can get that. What else are you going to tell me? What about location? What are you going to tell me about your location? Main Street. That would probably be the Main Street in Alamosa. The other kind of thing to note is if you tell us you're by a Dunks, we can probably Google it. And we'll also figure out that you're not in Alamosa. So call it different by the service office. But say that was in Alamosa. Be like, I'm by the Dunkin' Donuts on Main Street, and this is the time. It's halfway up a Mercedes-Benz or halfway up a car, and it's deep. Okay.
Well, you have the fire department on scene.
Yep.
Wouldn't you be getting a report from them?
I don't know. They might be busy saving lives, which is what matters in their field. Our field, you know, yes, we're trying to save lives, but we're in a different kind of way, right? They're probably busy. And this is, you actually bring up a really, really good point with this too. Assume that you're the first person to call us, okay? No matter how many calls we get, it's good to have multiple reports. Assume you're the first person that sees this and who's gonna call us.
I was a firefighter in 1 in 10 years, and we never reported anything.
Yep. They're busy people.
We didn't have direct communication source.
Yep. Yep.
No. We had some interesting fire information like that, other than that, other stuff.
Yeah, but I'm just assuming that if you arrive on scene, you're gonna notify dispatch
Sure, so
that they're
yes, but
at the scene of a flooded intersection.
Like,
Yeah.
think about it this way, like, first responders are busy doing their job and they can probably give a crap about us because they're trying to save some people. So like, as an observer on this, again, if you're not trying to save lives, give us a call. That's great. And assume that you're the first person to call.
Okay.
Okay. It's a good question. I like that conversation. Thank you. All right. So we know that. Simulation 4. A line of strong thunderstorms is tracking across the eastern plains. Looks something like this on radar. Also, that's Chicago. That's not the eastern plains. It's Alabama. But say this was on our eastern plains. That's pretty foreboding, right? It's a little ominous. That's a line of, does anybody know what that radar pattern is called? I heard bow echo. Bow echo's the right one. Nice. So that's a bow echo. The point on this, if you're looking at the radar, you start seeing this, this is probably where the strongest winds are. The area, like the concavity where it kind of apexes right here, that's generally where the strongest winds are. The winds will likely be weaker here, weaker here. Also, other things that can happen with these, at this point where it's, again, the vertex essentially of this, you can start seeing little spin ups and tornadoes, but that's beside the point. These are associated with strong winds. So the National Weather Service issues a severe thunderstorm warning across the entire line of storms, citing the possibility of 75-mile-an-hour wind gusts and 1-inch hail. Taking a peek outside the window, this is what you see. What is it? Shelf cloud. Is it reportable? No. It's not reportable. So by looking at this, we assume that there's a shelf cloud with that. That's a shelf cloud. The shelf cloud itself is not reportable. The winds are. So when that goes over you, which it looks like it's coming towards you, that's when it's reportable. The shelf cloud's not reportable. It's great to know that it's there, but we probably already know it's there. So after the storm has passed, that is that reportable? Perfect. How are you going to report that? I hear a lot of good things. I heard take a picture. We'd love that. I heard look at the size that snapped. I like that. Are you going to go towards it? No, especially this one. Perfect. I'm glad you're listening. But, you know, especially in this case right here, who knows if, I guess, who's your CSU? Is it up here? Who's your provider? CSU. Down in Pueblo, it's Black Hills. Who knows if they cut the power to that quite yet? It's a live wire potentially. We don't want to find out, right? So just estimate. You can give us a little bit of an idea about, you know, if a tree was rotted or if it's a hardwood versus a softwood, if you know that. AKA just to tell us if there's damage. Get an estimate about how wide the limbs that are falling. But when I was doing this talk in Lamar, got a bunch of people like, I'll be cutting that thing down. Of course I'm going to it. Talking about using the chainsaw on it, which makes sense. Somebody has to do it, right? So anyways, there's that. So spotter safety, don't go anywhere near the downed or damaged lines ever. Report the wind, just say that it's the tree that's fallen. You did it. Thank you for your time. This is the password, and I do want to show how to use this really quickly. I'm going to come back to this, okay? Thank you so much. All right, so at this website, weather.gov/pub/spotters, you'd go to here where it says certificate and hail card. Here. We'll get out of here, Edge. Skywarn, submit, and then it'll create that, and then it'll create that. If you right click this, save image as, you can save a file of this, and you can print it off, and it'll be large. If you do the same thing with this one, save image as, when you print it off, I did some testing, so it should be exactly 1 inch when it prints off on the hail card. There you go. So let me go back. Thank you. So there's the password. I'll leave it up here for just a moment. And then my email's at the end of it. Okay, doesn't look like people are writing down. So there's my email. So yeah, that's it. Thank you guys for attending. You're a good crowd, really interactive. I appreciate your time.
Thanks.
Yeah. Does anybody have any questions?
Quick question.
Yeah.
Do you still use the database of previous spotter IDs?
We do. Yep. So if you have a spotter ID already, we still use that. Use it. Tell us about it.
Dick will be adding the family. Even though you don't
Yeah.
If we're recording home, is that a pretty quick location?
Yeah. If you have your call sign you're talking about?
No,
The spotter ID. Yep, they'll go straight to your house. Yeah, it just gets a little bit obviously more complicated if you're out and about.
Is it easy? Yeah. But if we're at home, it's easy for you to just use that.
For sure. For sure.
What's that last example? Was that a derecho?
That could have been that derecho. Yeah, it looks like that on radar when derecho. What's that?
Yes, big enough.
It has to go long enough. So the size isn't necessarily the thing, it's the longevity of how far it tracks. All right. Cool. Thank you guys so much.
So, my name's Terry Kipp, K0IFT. I run the daily weather net. How many have logged into a weather net so far? Anybody? A few? Okay. How many know Sid White, K4ARM? Okay. He ran the daily weather net so far back that he can't remember when he started. But old age has caught up with him. And last year he decided he can't do it every day. He's still the EC for weather ops, but he asked for a volunteer. And since I've helped him quite a few years, I took over. So that's why, you probably won't hear him too often. He's got his radio problems, but anyway, so the WeatherNet runs every day starting today, the 15th, runs through September 30th at 12:30 every day. Again, the repeaters 147.345, 107.2 hertz, 146.97, and that's 100 hertz. When we start the WeatherNet, I go on the frequency, I give this nice little speech, and then I will read the outlook that Pueblo puts out, if there is one. When that's done, I will call Pueblo and ask if there's an update. They'll tell me yes, no, they won't answer. And then we go ahead and everybody check in. When you check in, I'm looking for your call sign phonetically, your name, what city you're in, and then repeat your call sign. I don't need anything specific location, just city, monument, fountain, whatever. If there's no outlook, I'll just say that, we'll just check in, and that's it. That's about 5 minutes. Pueblo Weather will tell me if there's going to be a 3:30 update. The 3:30 update is an update where the weather's getting worse. So Pueblo will either say, go ahead and run a 3:30 update, they'll come out with an announcement later. Or he may say, we don't need a 3:30 update, or he'll tell us, don't do it because the weather's going to hit 2 o'clock. So there's no point in doing a 3:30 update. But the 3:30 update is exactly the same thing. I will read the updated outlook. It will do again, the call sign, name, city, and repeat the call sign, and that's it. when we run an actual severe weather severe weather net, Pueblo Weather will tell us to do that. I don't determine that. That's up to them. The difference is a lot longer speech, and we'll have you check in, same thing, your call sign, your name. This time I need your exact location, either by saying your mobile or give me your nearest major intersection. That way, when you report a funnel cloud or something, I can at least know where you're at. So, and when you check in, if you have reportable weather, tell me. If the weather's nice, I don't care. Don't tell me it's sunny or it's cloudy and it's light winds. We want reportable weather, and that just takes some time. So we'll run that as long as the severe weather lasts, and Pueblo Weather will tell us that's it. Okay, we're going to cancel it. In that case, we'll just sign off and go. If you're on the weather net, the severe weather net, and you need to leave, you can't stay on, let me know, especially if you're mobile. So I know that you've arrived there. If we cancel the weather net, I may hang around for a little bit, but we just need to know that you're safe. We'll do an occasional, what I call informal net. I know the storm's coming. I see some stuff out there, and I'll log into the net, and guys will give me some reports. I might pass it on to Pueblo if it sounds interesting, but at least I keep an eye on what's going on. Then Pueblo will jump in and say, okay, let's go ahead and make this official. So there's three types. There's the 1230, 330, and a severe weather net. The one thing, and I'll ask you to do, he's covered most of the stuff I was going to talk about weather-wise. If you report a rotation in the clouds, I will normally ask for somebody else to confirm that. Because if you're looking at a rotation off that distance, and this happened to me, I was driving around my Union Academy going to my home, and somebody said there was rotation right above where I was at. So I looked up. Now the clouds were going this way, but there's no rotation yet. But a half an hour later, when I got over Fallon, yeah, then here come the funnel cloud. But so don't be insulted if I ask for somebody to verify that. We are storm spotters. We're not storm chasers. That's a completely different animal. We don't chase after things. If you want to go chase after a tornado that you saw there, fine. Let me know you're gone. Give me your next of kin, and we'll let you go on. But we don't chase after storm. We just spot there and look. If you're mobile and you're driving along, you just came off 25, you're driving out Woodman to go out to Falcon, and we've had a report that Sand Creek is kind of flooding. When you go by, I may ask you to check on that. Just drive by and look what's going on. If you're downtown and we've heard Mountain Creek or Fountain Creek is kind of overflowing, and I'll say, can you go take a look at that? Just stay safe. It's nice for us to know that and let them know. There's several rain gauges that I can check onto that way. Yeah, blue sky reports. Really, that's about it. He covered most of the stuff I was going to cover. Again, the hail, start, stop. Even if you got one inch hail and the rest are all half inch, we want that 1 inch. We want the start time, end time. And that's going to be for most, like for the heavy rain. When the heavy rain starts, when it stop, let me know, and then we can pass it on. The reports that you give to me, I'll call them and say, hey, do you want this report? Sometimes they'll be listening in. Anybody remember that day in August where we had all those tornadoes all over the county? He just said, talk, I'll listen. I don't send anything to him. It was just constantly all day long, tornadoes, funnel clouds, hail. If it's that busy, we've got to be really precise. Tell me what you've got, and then give me your, do your call sign to sign off, and I'll write it down. We don't want to expand that to where it's going to last 2 or 3 minutes while you're giving me the report. Just tell me what it is, sign off. If I don't understand, I'll ask you. But the main thing, the busier it gets with the weather, the more we have to be precise. And I guarantee you, there was one time during that tornado day, somebody in the middle of the whole thing gave me a report and then started talking for a couple seconds about whatever. He came on and said to us, keep it precise. So they do listen and they do want it done a certain way. So really that's it. I'm going to be on tomorrow. I'll be running it for my car this time. Starting Wednesday, I'll be driving to California for a wedding. I'll be gone for a week. But John, CFW, Dick Stewart, KD80Q, he helps out. If somebody is not there for the 12:30 briefing, don't worry about it. If you have something that's reportable, go through what he said. Go to the website. There's all these options to report it. If you have 2-inch hail and you try to call the net and nobody answers, send it to them. You don't have to have net control to file a report. I'm just somebody who congregates all this stuff together, and when they come on the frequency, well, what have you got? And I said, well, I have this report here, this report there, and that report there. And then he'll say, okay, let's go ahead and make it a official severe weather net. Most of the time, most of the 12:30, that's gonna be it for the day, because it's nice weather. I'm like, today we're supposed to get snow. Are we still getting snow tonight? Okay, that surprised me when I saw that outlook, so. But most of the time, it's gonna be severe clear. We're gonna do a 12:30 report, take about 15 minutes, and we're done for the day.
One thing, if you give your spotter ID, like your mobile in a completely different part of town.
Right,
Give your location.
Yeah, location.
Your spotter.
spotter, you guys won't get it, but if you hear somebody, if you got a spotter ID, then that is for that one location. If you're driving around town, don't give it to me, just say mobile. And don't tell me where you're mobile, because if you give me your mobile and you check in half an hour later, you're 10 miles away, you know, that location doesn't matter. So if you're mobile and you give me a report, tell me where it's at. Okay, go ahead.
Having a spotter ID, I'm at home. Rather have my location or the spotter ID.
Is your spotter ID for your home?
If I'm at home, I have spotter ID, which is more beneficial for you, spotter ID or my location.
If you're at your spotter ID, then you give me the spotter ID. If you got a spotter ID, kind of tells me that you've had the training. Well, back then, before they stopped giving it out. But if your spotter ID is for Monument, maybe where you work, but you're at home in Fountain, that doesn't matter. I need to know where you're at. So if you're not at where that spotter ID address is, because when I pull up Google Earth and I click on your spotter ID and it says that's in Monument, but you're actually in town someplace, then the reports won't matter.
Is there a way via hearing spotter IDs and or locations for somebody like yourself to figure out what these reports are?
Yeah, yes.
Stuart sent out Google Maps that has all the spotter
You'll
IDs.
send a KML file.
Yeah.
That you can put into Google Earth. And it will plot every
It's
single
really
spotter
nice.
ID.
How is that
that he
available?
has.
How is that available?
He sent it via email
Send-
to you if you ask for it.
Yeah, it's
I got too many people answer.
KDAEQ,
go KD80Q@ARR.net. Ask him for that, download Google Earth, and then you upload the attachment into Google Earth. And when you open it up, you got this nice little column of all the spotters. You click on one and boom, there he is. You know exactly, if he's at that location. Yeah, go ahead.
We also, Dick provides it to me, we posted in the download section of the PPRAA.org website.
Oh, it is?
So
Okay.
if you go to PPRAA.org and you look at the menu across, hit downloads, you should find it at the
Yeah.
top there. So he is, when I post it there.
And he was going to be putting in your call, if you don't have a spotter number, your call sign. Same thing, you just scroll down to if you have the call sign, click on that and boom, it'll show up on the map. Nice satellite view. And did you have a question also?
Yeah, the one thing is, if you can't get on the net at 12:30, you know, you might have that job thing or something, or you're traveling. Even if you're traveling, you go on the website for weather.gov, and basically what they read is the weather forecast. And in the hazardous weather outlook, they will say whether
Right.
spotters will be needed, possibility of spotters.
Right, possibility,
So if
yeah.
you're in the middle of Kansas on vacation.
Yeah, certain words they use will tell you how bad the weather
And
is.
don't get thrown off because if we start talking about Leadville and everything else, eventually we'll get that.
Yeah, and then the reason we do it is I can pull it out for everybody at one time, put it over the radio, and you're done for the day. When Pueblo weather, if he comes on during the 12:30, he'll kind of tell us. So at 5 o'clock, look for this to start happening. When when we had that tornado day last August, he told me the day before for the 12:30 briefing, that was coming. So we knew that was, and it worked great except for that one little glitch. We had all kinds of reports, and so it worked perfectly, I thought. So
You want time in UTC or local?
we just work local. I can't add that high. Anything else? That was nice and sweet, short.
All right.
Okay.
Thank you so much.
All right, thank you.